right, so that first page, we needed to find out how many sections there were. 140 divided by our 5 centimeters for each section. We found out there were 28 sections. Then we want to take off the start of the next pattern. So we subtracted that 1 from it. And then we divided up by the 3 colors that we have to find our answer of how many sections will be blue. Let's look at our next section. This number has 4 digits. Every digit is an odd number. None of the digits is a 9. So my odd numbers, 1, 3, 5, and 7.
That's the answer?
No. We haven't read the whole thing yet. You have to read the whole problem. Every digit in the number is different. So there's no repeats. The smallest digit is in the thousands place. So you're going to want to put the smallest digit in the thousands place. The greatest digit is in the ones place. We have 2 digits left. The number is the greater of the 2 possibilities. So if we had a 2 and a 4 left, would I want to put 24 or 42? You want to put the greater of the 2 possible combinations. That's your answer. Landon? We're not going to say the answer. People need to write it down. If you have a question, you turn it in, and I will check it over. Shh. 5-card challenge. Doing your order of operations, trying to equal it to be 2. You cannot repeat your order. Josie and Zoe, I sure hope we're not talking as we're finishing that test. Math 6 needs to make it 12 points. Try to challenge yourself. Instead of just doing simple ones, 5 minus 3 is 2. Try to do some more complicated order of operations, multiplying, dividing, working with negative numbers. Okay, you can make this more complicated working on your number operations. Shh. Find the area of the shaded region. So we have a big rectangle, and we have a small rectangle, and we want to know this goofy shape that goes around it. So how am I going to find that? Brielle? Yeah. First thing I have to do is find the area of the big figure, that big rectangle. Length times width. So my length is 30, my width is 15. Can I jump right to saying what that shaded area is now? If I found the big rectangle, can I jump right to it? Or do I have another step I have to do? If I find what the big rectangle is, how do I find the shaded area? What do I have to do? I have my big rectangle. I am cutting out my small rectangle. And I'm going to be left with this shaded area. So how do I find that area, Will?
Don't you have to find the area of the smaller rectangle and subtract it?
I need to find the white area. So I need to figure out my length and width of the white area. If it is 30 long and 8 of it is with the shaded, what is the white length? Brielle? 30 minus 8 is 22. Then here, we know it's 15 for the width, and 4 of it is with the shaded. So how much is the white? Nick?
11.
11. So same math that we did, length times width, 22 times 11 is our white area. How can I find my shaded area if I know the full figure and I know the white? How do I know what I'm left with the shaded? Well, we have to subtract the two. You have to subtract the white area out of the big figure. And you are left with that shaded part.
Oh, I forgot what.
So you have to find that full area, subtract out your white area, and you will be left with the shaded area. Any questions on that one? Yes.
When you're doing find the totals of each one and you
Subtract them because you want to find what's left when you take away. Take away means subtract. You take away the white. So you subtract out the white. All right. First 4 figures of a pattern are below. Study them and answer the question assigned to your class. So on your paper, they're not actually colored in. They're black and white. But we can tell what's yellow and what's blue. So we need to find out how many blue blocks are in each figure. So if we look at figure number 1, how many blue blocks are there? 0. There aren't any. How many blue blocks are in figure 2? 4. How many blue blocks are in figure 3?
16.
And how many blue blocks are in figure 4? 36. These are my favorite kind of numbers. Who remembers what my favorite kind of numbers are?
Even numbers? Even odd numbers.
Even.
No.
Odd numbers.
The next one is not 144.
Wait.
These are perfect squares.
Oh.
So how do I get to 4? 4 is a perfect square of what? What number do I multiply by itself? 2 squared. 16 is the perfect square of what? 4. 4 times 4 gives me 16. 36 is a perfect square of what?
16.
Nolan?
What?
36 is a perfect square of what? You were raising your hand. Did you have an answer, or were you raising it for something else?
Oh no, I was stretching.
Oh, Will. 6 times 6 is 36. Do you see my pattern?
Oh, I don't
2 squared,
know.
4 squared,
Yeah, I don't even know
6
why.
squared. Next would be 8 squared. I have my even numbers, and I need to square them. So what's my next one after 8 squared? What's my next number after 8 squared? 10 squared. Okay, so you need to go down and find those patterns. Find the pattern and find what number counts. So you need to do the math for each of those boxes. Always be looking for those patterns. Perfect squares are fun patterns to find. Get out your math packet number 8, Tristan. You've been missing some of our time going over it. Oh, our volume page.
Yay.
Shh. Now, if we look at this page, Math 6 needs to do 2 of them. I am going to give you the formulas for each of these shapes for their volume. Okay. I will walk through how to solve it, but you only need to do it for 2. So the formula for the volume of a rectangular prism is length, that's width, times height. For a cube, it would be the side cubed because they're all the same length. Length times width times height, they're all the same number. For the triangular prism, we have that length times width times height, and then we divide it in half. For our pyramid, we have that length times width times height, and we divide it by 3 because it's a pyramid. For a cylinder, we have pi r squared times the height. Because a circle area is pi r squared. For the cylinder, we multiply the height with it. For our cone, we have that circle of pi r squared. And then that height, we're going to divide it by 3. Because it is a cone, so we have to divide by 3. And the formula for a sphere is 4/3 times pi r cubed. Who can remind me what number is pi, Brielle? 3.14. And when we're looking at our r, what does r mean? The radius. Remember that radius goes from the middle of our circle out to the side. So some of us are going to look at this and say, oh, easy. I have length, width, and height. I can take my 144 and divide it by 3 because there's 3 sides. So if we take 144 and divide it by 3, what do we get?
Oh, you got 48.
Yeah. If I do 48 times 48 times 48,
Oh, it's too big of a number.
it is too big of a number. You cannot just divide it by 3.
You're not that smart.
What was that?
Can't you do it with the cube?
So when it's the cube, it's the same thing. You can't just divide it by 3 because then you multiply those 3 together and it's going to be way too big of a number. So let's look at, who knows, 144 is a perfect square. Anybody know what number 144 is a perfect square of? Kira? 12. If I were to do just 12 times 12, I would get 144.
But it doesn't work.
But we have 3 sides, not 2. Can I break down my 12 into 2 numbers?
Yeah.
What 2 numbers? I could do 6 and 2. I could do 3 and 4. I could do 12 and 1. So if I multiply 12 times 6 times 2, it's the same as saying 12 times 12. Because we know 6 times 2 is 12. So there we go, getting 3 sides that I can plug in, 1 for the length, 1 for the width, and 1 for the height. So you cannot just divide it by 3. You have to think of what 3 numbers when I multiply them together. Now, looking at the cube, I saw it equaled 729. And I thought, well, I like my multiples of 10. So let me guess and check. 10 times 10 times 10. What does that get me?
1,000.
Gives me 1,000. 1,000 is too big. So I'm going to guess and check a smaller digit. Okay, instead of 10 times 10 times 10, because that would be side cube, I'm going to guess a smaller number. And I'm going to see, is that too small? Do I need to go bigger? Or is it too big and I need to go even smaller? We are not going to shout out answers. Okay? But we are just going to, you can guess and check what number can you multiply by itself 3 times. Some of these other formulas are a little bit trickier. I look at my triangular prism, and I see at the end I'm dividing by 2. So my first step is going to be multiplying it by 2. So 80 times 2 is 160. Now what 3 numbers can I multiply together to get 160? Because then I know I'm going to divide them by 2 to get 80. Same thing with my pyramid. I'm going to multiply it by 3 and then see what 3 numbers I multiply together to get that. We get an idea of how to work with these formulas?
Yeah.
If you're one of my friends who's kind of whipping through this packet and you're saying, oh, I'm doing great, challenge yourself to do some of these harder formulas. See if you can go above and beyond. That's how I had a lot of people at conferences say, hey, my goal is to do better on the math tests in the spring. And I know geometry wasn't a strong suit. It was a weakness on my test. Challenge yourself. This is a great way for you to be working on more math skills. That is our last page in this packet. So I'm going to stop the recording.